Picture this. You're a kid sitting on the living room rug, and you just dumped a giant tub of Lego bricks onto the floor. Now, nobody handed you a structural engineering manual on the physics of plastic load-bearing compression before you built your first spaceship, right? Of course not. You just grabbed two pieces that looked cool, snapped them together, and literally played your way into understanding how they worked. Well, in today's Explainer, we're diving into a fascinating methodology called play-first programming. And as you'll see, that exact same childhood mindset is unlocking the ability to create software for, well, absolutely anyone.
Let's be real for a second. For almost 50 years, learning how to program a computer was essentially a rigid, grueling hazing ritual. It looked exactly the same for everyone. You sat down with a 1,000-page textbook, you memorized exactly where every single semicolon was supposed to go, and you wrote incredibly boring introductory programs to do things like, calculate the area of a triangle. Your brilliant, creative ideas, they had to sit on a dusty shelf for months, sometimes years, waiting for a permission slip from a computer science degree.
But the world has changed practically overnight. The old timeline was learn, practice, then build. It was cold and honestly super frustrating if you're a creative person. But with the arrival of artificial intelligence tools, think Claude, ChatGPT, DeepSeek, that massive wall between your imagination and working technology, it's completely shattered. We are living in a totally new timeline. Imagine, build with AI, play, and then learn. Plain English is literally the new programming language. You don't start with rules anymore, you start with a toy.
So what does it actually mean to learn in this new era? Well, you've probably heard the term vibe coding. Vibe coding is this incredible superpower where you tell an AI what you want, let it do 100% of the heavy lifting, and you just sit back and enjoy the prototype. But vibe coding hits a really hard ceiling the second the app breaks or does something unexpected, mostly because you don't know what to ask for next. Play-first programming is different. It's the campfire you build around that initial vibe coding spark. It's all about taking the AI's code, intentionally tweaking it, and breaking it to develop real, tangible intuition and control. Okay, let's dive into the actual methodology. Think of this as your core sandbox operating system. The Play First loop has 4 simple steps, and these apply to literally every software idea you will ever have. Step 1, imagine. You just start with a what-if kind of curiosity. Step 2, prompt. Ask the AI to build it using plain English. Step 3, play. Just run the code, observe how it feels. And step 4, this is the absolutely crucial one, tweak and break. You go in, change one single number or word in that code, and just see what happens.
What's genuinely astonishing here is the barrier to entry. If you're an absolute beginner, you're probably thinking you need some expensive, intimidating developer setup, right? No way. You only need 2 things, and they're already on your computer right now. A basic text notepad, like Windows Notepad or Mac TextEdit, and your favorite web browser. That is the whole shebang. We're using HTML, which is basically the raw, beautiful skeleton of the internet. You just paste your AI-generated code into the notepad, save it as an HTML file, and open it in your browser.
Let's move to our first tactical experiment so you can see how this builds. Project 1 is called Drifting Stars. Following our loop, we imagine a sleek, midnight black container right in our browser, where tiny, neon-tinted stars drift across the screen, pulsing with this soft light. We give our AI assistant the prompt, asking for exactly that in a single HTML file. The AI hands us the code. We paste it into our notepad, double-click the file, and suddenly, boom, we have a calm cosmic sky living right on our desktop. We are officially vibe coding.
But now we take control. We move to step 4, tweak and break. Imagine looking at that code in your notepad and finding the line that literally says star count equals 50. You reach in, twist that digital knob, and change the 50 to 2,000. Then you find the speed math and multiply it by 25. You hit save and you click refresh on your browser. So what happens when you break the speed limit like that? Let me tell you, the visceral thrill of this moment is just incredible. Your calm, floating night sky instantly transforms into a raging, vibrating hyperdrive simulation right before your eyes. The stars aren't drifting anymore. They are teleporting fireflies absolutely tearing across your screen. And the best part? The browser doesn't crash. It effortlessly maps 2,000 unique moving vectors just because you told it to.
Now, here's the crazy part. While you were busy creating all this visual chaos just to see what would happen, your brain naturally absorbed foundational computer science concepts without you looking at a single flashcard. You learned the canvas DOM, basically understanding how browsers draw pixels. You learned X and Y coordinate space by messing with velocity. And you learn the animation frame render loop, realizing that digital movement is really just an illusion created 60 times a second. You learned all of that just by playing.
Okay, let's level up. Project 2 introduces real physics. We ask the AI for a bouncing colors and light trails sandbox. This time, we want solid, glowing neon marbles that don't just float, but realistically bounce off the boundaries of the canvas. We're talking real mathematical collision physics, brought to life in seconds.
Once again, we look under the hood and start twisting dials. First, we find the background fade setting and change the alpha transparency decay to an incredibly small number, something like 0.005. Next, instead of just letting the marbles bounce normally, we change the math so they absorb kinetic energy and speed up by 40% every single time they hit a wall. We are literally defying gravity here.
When you refresh the browser this time, those tiny marbles inflate into these lumbering beach balls that just accelerate into abstract lightning bolts. And because you tweaked that transparency, they become infinite calligraphy brushes painting a permanent, hyper-bright neon tapestry across the screen. Just by changing 1 decimal point, you mastered what professionals call alpha transparency accumulation. You learned advanced layer blending and motion blur in, 5 seconds?
Up to now, we've been hacking the code manually in our notepad. Project 3 is the ultimate sandbox upgrade. We call it the Chaos Equalizer. For this, we have the AI build an actual hardware-style dashboard right on the screen. We're talking physical sliding knobs sitting underneath our visual canvas that let us manipulate the size, speed, and chaos of orbiting particles in real time using our mouse. No notepad editing required for this part. So, what's the tweak when the knobs are already built in? Well, we push the code way past its safety limits. We dive in and basically crosswire the circuits. We take the aesthetic color engine, the hue, saturation, and lightness, or HSL, and we bind it directly to the physical speed slider. We are literally linking the physics of the application directly to the aesthetics.
The visual result? It's pure magic. Your particles become dynamic mood rings. They glow this cool ice blue when they're moving slowly, but the second you push that speed slider up, they blush into a warning neon red. And in doing so, you've completely demystified advanced mechanics like dynamic DOM binding and event listeners. You've naturally learned how data can dynamically drive visual changes.
Now look, inevitably, when you play like this, you're going to break things. The screen will go completely blank. In traditional coding classes, a red error message brings this dark cloud of absolute panic. But in this clubhouse, we radically reframe errors. Actually, scratch that. A bug is not a failure at all. It is simply a landmark. It's a celebratory GPS ping showing you exactly where the edge of the digital map is. Honestly, if you aren't breaking the code, you aren't playing hard enough.
So how do we handle these landmarks? We use the Hidden Browser Developer Console and a really simple 3-step debugging loop. Step 1. Open the console. Don't even try to guess what went wrong. Just copy that intimidating red error text. Step 2. Paste it right back into your AI along with your code using a plain English prompt. Just ask the AI, hey, what boundary did I accidentally cross? Step 3. Observe the fix. It completely empowers you to fix broken code effortlessly and, best of all, totally stress-free.
Sometimes, though, you might add way too many features at once, and the AI just gets confused trying to fix its own code. It happens. That's when you use the scale back rule. You simply isolate your experiments. You tell the AI, okay, let's pause. Let's return to the absolute simplest working version of the canvas. Once you've got that running smoothly again, you just incrementally add your features back one by one. You stay in total control of the sandbox the whole time.
And this brings us to a really beautiful resolution in our learning journey. You might be sitting there wondering, okay, this is fun, but can I build something actually useful this way? The answer is an absolute, undeniable yes. This is what we call the campfire principle. You start with digital clay, just mashing toys together. But eventually, you build a toy, maybe it's a visual planner or a customizable reading timer, that you find yourself coming back to. When you spend time playing with it, cleaning up the design layer by layer, it naturally matures into a real, useful application. The toy earns the right to become a tool.
And you can take these tools anywhere. You can expand your sandbox infinitely just by dropping prompt modifiers into your AI chat. Add the mouse spawner to generate particles exactly where you click. Use the gravity well to pull objects straight to your cursor. Implement the wrapping warp to completely break real-world physics. Or use the cyberpunk overhaul to instantly redesign your entire playground in neon magenta and electric cyan. The variations are literally endless.
I want you to remember the golden rule of this clubhouse. If you enjoyed making it, it worked. Period. Software creation now belongs to you.
You don't need a massive tech company's permission, you don't need a crazy budget, and you for sure don't need a university certificate. Your curiosity is the absolute only qualification required to be here.
So, what does this all mean for you? What will you build in your sandbox? You have a computer, you have an AI partner, and you have your imagination. That's it. Open a text notepad today, start twisting some digital knobs, and bring your wildest ideas to life. Keep asking, what if?